I'm going to briefly describe how to use this interactive simulation, which is of a reactor with recycle, and we're interested in essentially the mass balances. So the idea is two reactions take place. The product that we desire to form is B. So this reaction selectivity, that refers to, at this point, what's the flow rate of B over the flow rate of C. So this molar flow rate of B. The recycle ratio, which I set with a slider, that refers to the ratio of A and this recycle divided by the fresh feed coming into the reactor. So you can see it's 0.46 in this case. And then the reaction conversion again refers to here to the percent of A that reacts. So it can react to either B or C. So in the simulation, B and C form. All three, A, B, and C, enter the separations unit. B, C, and some A is removed, and then much of the A is separated and recycled back to the system. So down here we show the overall conversion of A. That's different in the conversion at this point. What that refers to is how much of A is reacted. 100 moles come in. If 15 leave, then 84.7% of A has been converted to either B or C. The yield then is how much of that 100, what percent has been converted to B. B is our desired product. So let's look briefly at the simulation to understand how things change as we change the conversion, the recycle ratio, selectivity. So here's the simulation. The recycle ratio is set at 0, and you'll notice then that the overall conversion, 51%, that's also the conversion through the reactor because there's no recycle. Now as I increase the recycle ratio, keep the reactor conversion, in other words, what percent of A entering this reactor is converted to products, keep that at 51%. Notice I increase the overall conversion to 87.8%. A flows through the reactor a second time, and so we convert more of it to B or C. Reaction selectivity is the ratio of B to C. So I've changed the reactor selectivity to 2, and so the ratio of B to C, you notice it's not exactly 2, but just because of significant figures, I'm only displaying 3 significant figures here. The recycle ratio, the reactor conversion, of course, I can also increase. And you'll notice if I increase it enough, then I can't satisfy mass balances because the amount that I'm recycling is not consistent with satisfying how much we're removing from the system. And so we get this error that's invalid specification. If I lower the recycle ratio, I can run at that higher conversion.